Yeah, g'day YouTubers, Tinker O'Toole again here with another video. Today we're going to talk about different chains, different grinds, but mainly focus on Hexa and how to dress the wheel up there for Hexa. We did a video in the past about it, but this time we're going to do something a little bit different and explain things a little bit different. So first of all, if we talk about the first chain that a lot of people use out there is a semi-chiseled chain. Semi-chiseled chain where the two corners intersect has a nice radius on it and a nice working point here. So this type of chain cuts quite well and tends to last a little bit longer than a full chisel. The full chisel, where the top plate and the side plate intersect, is virtually a very sharp corner and a very sharp point. So this working corner tends to go blunt a bit quicker, but cuts up to 10% more aggressive. So you'll get through your timber quicker. Next, Hexa invented or came up with the Hexa chain, which was primarily for the logging industry. So all the people out there that were out there logging in the forest, if they could reduce their cutting time by another 10% over full chisel, that would save them time. So Stihl are claiming that the Hexa is 10% faster than full chisel. That makes it 20% faster than semi. Anyway, the king is a square grind. That claims to be 10 to 15% faster than normal full chisel. So that's pretty fast, but tends to go blunt much quicker. Equally, what those four things share in common is the side plate. So the geometry, obviously, of the side plate has a fairly major role in clearing out the chips and the fibers up to maybe 20%. So if 80% of the top plate cutting angle is the main part that bites into the timber, and the side plate clears out the rest. And that's probably, I would say, up to 20% would be about fairly close, based on some of the results that you see between the full chisel, the Hexa, and the square grind in cutting performance based on a stopwatch on the same size log. Certainly when I did tests on the semi-chisel and the full chisel, definitely on the stopwatch, I got up to 12%. I'm going to do the same test on the Hexa and to see what we come up with. So first of all, one thing that I'll sort of clear out of the way, and if I'm talking angles, I don't want to get people confused between the Oregon grinders and the Stihl grinders. Oregon, if the wheel is at vertical position, they refer to this as 90 degrees at the top. So when you say you've got a 60-degree top plate cutting angle, you're turning from 90 to 60. So you're only moving 30 degrees. So this is referred to as 60 degrees top plate cutting angle, and you've moved from 30 degrees from the vertical over. On a Stihl USG, they use 0 degrees. So you'll go 10, 20, 30. Exactly the same angle, different reference point, and you're tipping to the left. So Oregon tip to the right, Stihl tip to the left. So I've got that out of the way. So hopefully I don't use the wrong angle, and I'm talking about Stihl only. So if we're talking about the Stihl, the angle, now I'm going to have to use a normal protractor reference here, that if we look at the angle of a Hexa, on the Stihl it's 30 degrees in and 30 degrees out. But if you actually measure it on a protractor, it comes to 120 degrees. So that's the spacing. So on the old Oregon, it would be 60 degrees in and 60 degrees out. So on the Stihl, 30 in, 30 out. Same thing, it's just using a different reference point. So therefore you need to dress the wheel. Now a wheel between the vertical and the horizontal axis is 90 degrees, so we need to increase that by an additional 30 degrees. We can achieve that by taking an angle, grinding with a silicon carbide dressing stone. If we're in the vertical position, which is about here, we can grind an additional 15 degrees off the horizontal plane. On the inside of the wheel, on the vertical axis, we can also tilt this another 15 degrees and get another 15 degrees on that axis, which gives us a total of 30 plus the 90 that we've already got. There's your 120 degrees. So hopefully that explains that in real terms of geometry. So what we need to do is to tilt this to the negative. Now, on an Oregon grinder, you can only set it at 90 degrees. So totally different procedure to do this on an Oregon. And I've already done a video on that. So on a Stihl USG grinder, that's pretty easy to do. That's just a matter of turning this over to negative 15, which is right about there. We'll lock that into position. So now that we've tilted that over to the negative 15 degrees, we can put a beveled edge on the bottom of that. So start your grinder and you'll move this backwards and forwards until you've got it nice and flat, and there's your 15 degree beveled. We need to put another bevel on the inside, so what we need to do now is go to positive 15 degrees. So positive 15 degrees will be about there. Then what we need to do is hold the stone vertically, pull the grinding wheel down and grind a chamfer on the inside of the wheel. Now, the chamfer needs to only be 3.5 to 4 millimeters in length. Don't go any more than 4 millimeters, because the more that you push the stone over and grind off here, the skinnier the wheel gets. So you only, no more than 4 millimeters maximum. Anyway, if you've got a genuine Hexa chain and you put it in there, you can use that Hexa chain as your template as you dress the wheel, and if you're a little bit off, you can slightly redress it. So that's pretty straightforward. So if you've done that, your wheel's dressed. So you've added another 30 degrees to the 90 degrees, you've got your 120 degree angle, which is what Hexa is. So what you need to do now is to put this in a 45 degree angle, and that will be the grinding position of Hexa. So that's 45 degree angle. So that means now that you've got a 60 degree angle here and a 60 degree angle there, if we were to read off a protractor. And that means that you're going to get the Stihl Hexa grind. Now, as I said before, the side plate really does play a fairly important role in clearing out the chips, and where the two corners of the full chisel meet, you probably find the first millimeter does the hardest work of all. So we actually did grind a Hexa on here, and we'll zoom in and hopefully you can see it. We'll just lower the camera down a bit. I want to get right over the top of that. So, and when I was talking before about putting that bevel on, that 3 to 4 millimeter bevel on the vertical, that will be the top plate cutting angle here. And that's why I said don't put too much of a bevel on there, because you're only, what would it be? Look, it's probably just under 3 millimeters, that flat section there. Then you've got this section that goes down, and that's why I say that don't put a bevel more than 4 millimeters on. If you actually have a look at the Stihl Hexa, you'll find out that it's almost identical. Yeah, the one at the top is the one that I did, and the one down the bottom is the genuine Stihl Hexa. The only difference that you can see, there's a little bit more. If you look at the original Stihl Hexa, it comes down maybe slightly a little bit more on this angle. All you got to do is adjust the wheel, the depth of the wheel, to adjust that part there. So as you can see, it looks like it's a little bit shorter. Not that that's going to have anything dramatic on there, but that's the other thing. When you're using a grinding wheel, you can get that slightly out. Now, I do have a Hexa file here, And you'll notice on top, if you'll see the ridges on top of the Hexa file, and on one side of the file there's your 120 degrees, and on the bottom of the file, the opposite side, it's nice and flat, so that when that sits in the bottom here, that it doesn't grind any metal. Now, only one other thing to mention about the Stihl Hexa is that it's got a narrower kerf, which is the width of the tooth. So the width of the Hexa is 4.1 millimeters, and the width of this tooth here, which is a full chisel, standard full chisel chain that I use the Hexa grind on, is 4.55 millimeters. So it's a little bit wider. In a powerful saw, it's not going to make any difference, because the whole idea of having a narrower kerf is that you need less horsepower. So definitely you can do a Hexa grind on a powerful saw, say 72 cc's. You can not worry about that kerf. But if you've got a saw that's not as powerful, it may be a slight concern, but I don't think it's a major game changer. So it's just something to be aware of, that narrower kerf chains require less horsepower. So I guess it's a way of cheating, if you will. Anyway, thanks for watching. Give us a thumbs up. Bye for now.